Good morning, everybody. We're going to start together upper and lower bounds for today. We need to read our equation. 30 to the nearest whole number. To the nearest whole number, this means I need to round this 30 by taking every time on the number line the term and the next term. If I put it in order, it will become 30. Then the next number, it will be 31. And the previous number, it will be 29. So if I want to round it to the nearest whole number, this means I need to find the number which is between 29 and 30. If I round it to the nearest whole number, I'm going to get 30. So if I want to find this number, it will be 29.5. And the next number after 30, it will be 30.5. So in this case, I can say that the upper bound will be 30.5 and the lower bound, it will be, in this case, 29.5. Okay, I'm going for another way to find this one. If they will tell me to the nearest whole number, I'm going to put 1 in the place of the whole number. 1. So I want half of this one. So I'm going to get half. So by adding half to the given number and subtracting half from the given number, I'm going to get the upper and the lower bound. Okay, another example now. If we have 3.75 to the nearest 1 decimal place. Okay, to the nearest 1 decimal place, this means I want to put 1 in the first decimal place, which is 0.1. And if I want to take half of the 0.1, I'm going to get it equal to 0.05. This means by adding and subtracting 0.05 for my number, I'm going to get the upper and the lower bound. According to this, I'm going to say 3.75 plus 0.05, I'm going to get 3.8, which is the upper bound in this case. And by subtracting 0.05 from 3.75, I'm gonna get 3.7. So in this case, in adding, I'm gonna get this part. In subtracting, I'm gonna get this part. So in this case, I can know that the upper bound, it will be 3.8, and the lower bound, it will be, in this case, 3.7. Going for another example now. If I wanted to the nearest 10, the same thing, I'm going to take the half of 10, which is equal to 5. So by adding 5 to 25, I'm going to get 30 in this case, the upper bound. By subtracting 5, I'm going to get 20. So the upper bound is 30 and the lower bound is 20. Going for this number, 60.4, and I want to make it, let's say, to 2 decimal places. To 2 decimal places, I need to put 1 in the second decimal place, like 0.01. And taking the half of this one, I'm going to get 0.005. So in this case, 0.005, by adding and subtracting 0.005 to this number, I'm going to get the upper and the lower bound. So in this case, 0.4 plus 0.05, it will become 60.405, which is in this case, this is the upper bound. And if I want to find the lower bound, I'm going for 60.4 minus 0.05, I'm gonna get 60.395. So this is the lower bound. Remember to write the whole number. Don't write your answer if the question will ask you to find the upper and the lower bound. Okay. Going for another example now, if they will ask me to get it to 2 significant figure. In the second significant figure, we need to check in which place we should get the second significant figure in this question. The second significant figure is the second number after the first number, which is not equal to 0 from the left side. So if I'll put 1 in this place, the value of this one, it will be 0.001. And if I want to take half of this place, I'm going to get it 0.0005. So this means by adding and subtracting 0.0005, I'm going to get the upper and the lower bound of this number. Remember, Here I'll put 1 in the second significant figure because we have it here in this place. And if I want to find it to the second significant figure for this question, I'm going to put 1 here. I'm going to get the value of the 1 is 100. It's in the hundreds place. So if I want to get the half of 100, I'm going to get it 50. So by adding and subtracting 50 for my number, I'm going to get the upper and lower bound. Going for this example, I can't start with 0 saying that this is the first significant figure. The first significant figure is the first number from the left side, which is not equal to 0. So in this case, this is the first significant figure. But the question asked me to find the second significant figure. I can count starting from the first significant figure, the second significant figure. Even if it's equal to 0, we can count it as a second significant figure. So in this case, this is the second significant figure. I'm going to put my 1. It will be 0.001. So by taking half of this one, I'm going to get 0.005. Half of this one, it becomes 0.005. So in this case, by adding this amount and subtracting from my number, I'm going to get the upper and the lower bound of this number. Okay, going for 5,000 to the nearest 250. The same thing, I'm going to take half of the 250 and count it. I'm going to get it 125. So by adding and subtracting 125 to my number, I'm going to get the upper and the lower bound, and that's it. Okay, what about if they will ask me, we have 250 kilograms and I needed two significant figure. The same thing. Two significant figure, I'm going to start with the 5, saying it's 50. And it's 10, so the value of the 10 in this case, it will become 5, half of this. Adding and subtracting for this part, I'm gonna get what's the lower and the upper bound. In some cases, they will ask me, it's 250 and I want it to the nearest kilograms. To the nearest kilograms, if we have the same unit, I'm gonna say it's a whole number and add and subtract 0.5. So kilograms and kilograms, centimeter and centimeters, meter and meter. This means you are dealing with the whole number, and in this case you need to add and subtract 0.5. Okay, what about if I have 250 kilograms and I need it to the nearest gram? If the whole number is kilogram, this means the decimal place will give me gram. So according to this, I'm gonna put 0.1 and take the half of the 0.1 because it's the first decimal place in this case, which is representing for me grams, and say I need to add and subtract 0.05 to get the upper and the lower bound of my case, because here grams will represent for me the decimal part of the kilograms. Thank you. Okay, what about if they will give me x equal to 7, y equal to 9, and z equal to 10.3? And if they will ask me to find the upper and lower bound for each calculation to the first significant figure. We need every time to get a big number to multiply a big number by another big number. So in this case, if I want to multiply x and y to get the upper bound, I need to take the upper of x times the upper of y. So the best way to solve this question, to take each number and find its upper and lower bound to first significant figure. To the first significant figure, this means I need to add 0.5, so it becomes 7.5, and I'll subtract the same thing. So this is for 7, and after that I'm gonna do the same thing for 9 and 8.5, and I'm gonna do the same thing for 10.3. Add and subtract 0.5, it will become 10.8, and if I subtract it from here, I'm gonna get it 9.8, but I need to check also. 10.3 minus 0.5 will become 9.8. Now this is the upper bound and this is the lower bound for each number to the first significant figure. So if I want to multiply, I need to take something big with another thing big to get the bigger bound. Let's say in this case, I'm gonna say x, which is 7, the upper bound of this one times the upper bound, I'm gonna get the upper bound of the case, which is 7.5 times 9.5. I'm gonna get the answer 7.5 times 9.5, which is equal to 71.25. So this is the upper bound. And if I want to get the lower bound, I need to multiply 6.5 by 8.5 to get the lower bound. So the same thing, 6.5 times 8.5, which is equal to 55.25, which is the lower bound. So in this case, when we multiply, big with big give me upper bound, and small with small will give me the lower bound. Okay, and the division, it's totally different. So if I'll say, let's say 5, I'm going to divide it into 2. It will give me bigger number than 5 divided by 4. Okay, so in this case, this will be value 5 divided by 2 will give me 2.5, while 5 divided by 4 will give me 1.25. So this means if I divide big by small, I'm going to get the bigger amount or the upper bound, not big by another number. So if I'll go back to my work, I'm going to say, if I want to get the upper bound, I'm going to divide big by small. So I'm going to get the big number of x, which is 7.5, divided by the small number of y, which is 9, 8.5. So I'm going to get 7.5 divided by 8.5. I'm going to get 0.88235 and go on. Okay. Now, if I want to find the lower bound of this case, I'm going to say lower bound, I'm going to get it when I'll divide small by big. Okay, small by big. The small of x, I'm going to get it from here, 6.5, divided by the big of y. So it will become 6.5 divided by 9.5, which is equal to 0.68421 and go on. Okay, so according to this is the lower bound and this is the upper bound. Okay, but what about this case? We have here more than one calculation. First of all, we need to subtract and divide by y. This is what we are doing normally. If I want to subtract to get the big amount, I'm going to say big minus small. So if you can write it like this, if I want to start with the upper bound, I'm going to go like this. If I want to get big amount, so this means the upper part should be big and the down part should be small if I'll divide. Okay, but to go for the big amount up and we have subtraction, to get big amount, I need to say big minus small over small. Did you get it? So from x, I'm going to take the big amount, which is 7.5. From z, I'm going to take the small amount, which is 9.8. And from y, I'm going to take the small amount to get all of this as an upper bound. So the small amount of y, it will be 8.5. And after calculating all of this, I'm going to get 7.5 minus 9.8. And I'll divide the answer by 8.5. So my answer, it will be as a negative number, 0.2705. Okay? Now, what about if I want to get the lower bound of this one? First of all, I'm going to talk about the division. The lower bound, it will be small by big. So to get the upper part as a small, and we have subtraction here, I'm going to say small minus big over big. So small from x, it will be 6.5. And big from z, I'm going to get a 10.8. And big from y, I'm going to get 9.5. So if I'll calculate this, 6.5 minus 10.8, and I'll divide the answer by 9.5, I'm going to get 0.452 and go on. That's it. Thank you. Remember every time that the small amount in the negative number will be bigger than the big amount. Did you get it? So this is in this case the upper bound and this is the lower bound of the calculation. Thank you.